Awesome. Welcome all again to a Gateway Inference Extension meeting. It is the first week of February. I don't remember which day exactly, but this meeting is being recorded. We are uploading it to the cloud, so behave accordingly. And we do follow the CNCF guidelines, so let's all be nice to each other. First things first, we quite literally just released V0.1. So super exciting. Please, if anyone here is interested in kicking tires on it and finding where it breaks, please do. We'd love to hear about it. Yeah, excited to move forward, and hopefully this can unblock some of our gateway integrations that we're planning. A lot of work from basically everybody on this call. So thank you, all of you. This is awesome. Looking forward to a lot more. Other than that, we'll jump to Rob, who has a topic. Rob, take it away.
Yeah, so one of the things I am interested in this, well, maybe becoming part of the scope of this project, is an optional extension that would basically translate body params to header params. So as many of us are aware, OpenAI chat completion API that we're all trying to support has essentially puts the model name exclusively in the request body. And that's fine, but very challenging to route on. So one of the ideas is instead of trying to add a bunch of routing APIs for request body params, it would be potentially simpler to have something like before routing rules ran that basically picked up a body param, dropped it into a header, and then all routing params, except all routing rules would be based on that header instead. And at the same time, if that header was basically already set in as part of a request, we wouldn't need to run the extension at all. So it's basically just a shim idea to provide compatibility with OpenAI while also enabling efficient routing if your clients can set a header. Yeah, so that's an idea. Just surfacing this, fairly early to see if there's interest in this project specifically as kind of an optional extension that could be paired with the rest of this, or yeah, I'll leave it there. But
I have a couple of things. One is I think this is a great, operational win in general. It's not just operational, like a a new feature that's not quite related to performance, but it's related to like right now you have to have the client set the thing on the header, etc. So that's the operational win, right? Like it makes it a lot easier. Just do that automatically, and then you do routing, and then you can do body-based model name-based routing. So I think this is a great win in general if we can do that.
Yeah, exactly. I mean, this has been one of the biggest bits of pushback or feedback we've gotten when we've taken this to Gateway API, SIG Network, API review. Wait, you mean you have to look in the request body for a model name? It's just not something like you want to involve. So this is a way to ensure that, you don't have to.
But something is still doing that though, right?
Yes. Yeah. So the idea is that you would have an extension that basically acts as a shim here. So if the header is set, you don't look into the request body at all. It just keeps on going. But if the header is not set, you can go back and look in the request body for that param, basically. So it's encouraging as many clients as possible to upgrade and just set a request header. But if you have some clients that can't, that's basically a compatibility layer, I would say.
But like the point is we need to have it run before we made decision which HTTP route is selected. And does that fit in the Envoy model right now? Like we want to demo it.
It does. Envoy's XProc allows you to run an extension like this before routing is considered. So that's where I would propose this lives. This also, throwing the gateway API maintainer hat on, there's very little appetite to add any kind of routing APIs to do routing based on any params inside request body. So this would allow us to reuse, existing routing rules for headers, and basically pull this one step above.
Clayton.
I was gonna say, I assume this is a general problem that other people have a need for because of that, Rob. So, like, is the framing of this like this would be a fairly general example, even if there were specifics for our use case?
Yeah, I mean, it is generally applicable. I don't know of anyone other, I don't know of any common uses of body param routing other than, what OpenAI chat completion standard is. So,
Okay.
But it's generic enough. It could be used for anything. I just think this is likely going to be the most common use case.
Okay. Yeah, because I have seen this in the past, like older frameworks might have had aspects like this, but the kind of the unique thing here is that every body parameter is relevant, and path is kind of irrelevant. One more question would be, we engage, like, is there I may have missed this while I was out, are there any efforts to drive standardization of the OpenAI protocol across the different groups that do it? Like, is anybody even doing something as basic as making sure, like, defining it and ensuring that it's consistent, and that if OpenAI changes it, everybody doesn't break?
Yeah, there's something that's been started up. I haven't seen updates since maybe December, early January, something like that. But under Linux Foundation AI, there's been a group starting up to do standardization in this space. I don't know that it's necessarily strictly tied to OpenAI, but yeah, definitely trying to make this better and more. Yeah.
Could you link that in the doc? Because I was basically going to say,
absolutely.
I don't know why we wouldn't just go to all the other routing groups and be like, hey, we think this is really important. Do you guys care? Like Light LLM, SG Lane router. There's like 100, K-serve, et cetera. Like, are we kind of like all just being like, I hope somebody else solves this? And is there any place where we could say, yeah, hey, we view this as a problem, and this is the most concrete one. We wanted to recommend this as a pattern.
Yeah.
But here's how it would remain consistent. But everyone that we talk to would then potentially have the incident be like, oh, do you guys care about versioning of the API in case it changes under the covers? Oh yeah, we care about that too. Like, I just want to, if it's not going to happen fast in Linux Foundation, at a very minimum, we could probably name 10 open source projects that care about the stability of this API.
Yeah, +1. That's a great idea. I'll follow up.
I just had maybe it's an ignorant question, but if this runs before we apply any routes, how are we using the path? Can we still use the path to make sure we're not sniffing every single request that comes through? Because what if someone's mixing their gateway with other workloads? While that might not be best practice, I'm just curious.
Yeah, I mean, that's a good question. Envoy does allow you to conditionally attach an extension to a subset of paths, for example. But unfortunately, unfortunately, I have not seen any standard. There is not a standard way to do that in Gateway API itself. I know many Gateway implementations have their own APIs for this that could use kind of a standard image and a standard practice, and hopefully we can standardize this in Gateway API itself. But right now, it would rely on implementation specific extension config to point to this portable, I guess, image or extension.
Cool. Okay.
Cool. All right. Well, it sounds like there's some level of interest here. I will follow up with probably an issue or something to discuss a bit more. But if there's no objections, just we'll keep on moving from there.
Sweet. Sounds good. Moving right along, it looks like Daniel has something. Go ahead.
Yeah, I just wanted to make sure that we follow up from last week's action items. So if we scroll down, look at the action items from last week. I'll check that first box. I think we pretty much have them all covered. So we documented the release process. You exercised that today, Kellen. So I think we're good there. Created milestones and actually closed out the RC1 milestone. So if you go to milestones, you'll see that we still have 0, 1, 0. And it should be accurate as well. I'll take another look after the call. Let's see, there's an action item for Abdullah ping signet leads, Shane final review. Yep, yeah. So the config API merge, so everyone knows. And then these last two, I think, they're pretty much interrelated. You see, I provided an update, and I think Jeff, you're on the call with testing out VLLM with CPU instead of GPU. Just a few hours ago, I was able to test on my end in Docker, and I'm just trying to port that over to my test Kubernetes cluster. Was having some issues, but I think it's just a matter of working through some of those details. I'm not sure has anyone else run the CPU VLLM image that Jeff created as like a Kubernetes pod or deployment yet?
I have not. This is very cool though, but I have not.
Yeah. I noticed definitely a big difference, obviously, in the performance. But if we don't have to rely on GPU, essentially just for kind of end-to-end testing, it's pretty sweet. But Jeff, I believe you had some concerns too with running the image in CI due to the size of the model server image. You want to expand or share any information there?
Yes, I think functionally now it's working fine with all the features. I think this project depends on, right, like the LoRa, etc., like OpenAI compatible API. Those are all working in my environments, but I didn't test in Kubernetes, but I did test it in like Docker containers, so that's working fine. So the only concern is the disk size, and I think by default the GitHub runner, I kind of forgot the space issue. I did remember we made some disk issue in the past, but I'm not that sure like whether the CPU image can fit into the runner. It takes like 10 GB. I think it probably okay. Yeah. Yeah. So that's the only
Cool.
disk concern. Yeah.
Yeah, which it's better than having the GPU dependency. So, if we do run out of disk space on the GitHub runner, I would imagine we can expand the size of the disk. I don't know if anyone else has done that before or has any details. If so, feel free to add a link into the issue in case we do run into that problem.
We can test it out.
Yeah.
Nir, if I'm pronouncing your name correctly, excuse me if not, but go ahead.
Yeah. Hi. So I'm pretty new to the community. I'm from IBM. We're getting kind of interested in this project because we started to working on routing and inference workloads and such things on top of Kubernetes. I just wanted to say that if there are instructions documented, then I'll be happy to test the CPU-based VLLM and see if it works on my end. Of course, I'll update. So if there are some documentation instructions, I'm happy to help.
Cool.
Yeah, Nir,
Yeah.
we don't. Yeah, Nir, we
Go
don't
ahead.
have it documented as of yet because it's something we're still working through. But if you want to DM me offline, I'll I could help get you going. As I mentioned
Yeah.
just a minute ago, I'm working through just literally like an hour or two ago. I was able to run the CPU-based image locally via Docker, and so I'm just working through the details of converting that over to the Kate's deployment. But yeah, offline if you want to Slack me, and I should be able to help guide you through it, and then we can get a PR push to potentially to update the image. Well, I guess now would be a good time to ask that question. I mean, if this works, do we want to swap out the current llama image with what we're doing here with this Quen image for CPU?
I personally have no specific model opinions. I mean, especially for our CI, I think whatever works. Let's do that.
Okay.
Cool. Unless there's anything else, we'll move right along. I just wanted to call this out. We don't really have to get into this. We can at the end if there's time. But the criticality conversation, this was a point of debate within the API review, and it's been called out a couple times. I think we should start a conversation. I think there's ways that we can do it better. Absolutely. Would love feedback on that as we continue the conversation. Excuse me, but I've converted the issue into a discussion, so everyone feel free to chime in. Abdullah, go ahead.
I think it's useful to have a quick discussion now. I think Nir is on the call as well. We can brainstorm a little bit. What do you folks think? I think we have some time.
Yeah,
I'm fine with that.
Cool. Yeah. So just to give like a high level, description here. So the criticality is supposed to capture, this use case where you have, production versus test workload, and instead of going all the way to like full-fledged priority with unlimited or much bigger range, we thought that it's like most use cases you're gonna have really like 2 or 3 workloads where you want to differentiate between, and that's why we started with this let's call them bands of priority: critical, default, and shareable. Now, this doesn't mean that we can't expand this into more finer grained priority within those bands. So that was the thinking. Like we start with much focused or like limited capabilities, easier to explain, and at the same time easy to basically for users to choose from. Like they don't have to think about numbers or whatever. It's already predefined enums, and so they are easy to use. And at the same time, it's future proof in that like you can expand it. You can put other things under each band, not just priority, but maybe even performance objectives once we get to that in the future. Nir?
Yes. So at least in our use case in IBM, we're looking on the things from a different angle. So when I came to this Git repo, I was looking for the angle that prioritize requests by users or by organization or something that is identified on the request itself. So criticality helps me prioritize one model over the other. But if I want to prioritize customers, in our use case, we have like premium customers or paying customers, but not premium, or free tier for IBMers that are using internally IBM Cloud. So we want to somehow prioritize their workloads, their requests according to the requester. So who is requesting now the inference, right? And this field doesn't allow to do that. And I wasn't sure about the use case here. So I understand that I can use the criticality field to prioritize one model over the other. But my thinking was like some kind of a use case. So for example, some models, they do completions like interactive chat, while others, you can ask them to do summarization. And then if I want to prioritize one model over the other, then I would expect that the interactive model would be with higher priority because the user expects to get a response immediately, while in summarization, it makes sense that the user would wait longer. But as of today, at least many models that I know, they do both. So I'm not sure about prioritizing models was the right choice. But yeah, what do you guys think?
Abdul, I saw your hand go down, so I'm going to go to Clayton.
I just want to mention quickly that Clayton and I were talking a little bit about this. You could still do it on the client side by having different model names that clients can target depending on what their criticality is. The idea that we can translate this to the same target model allows you to enforce, priority across clients. And then when you have more finer grained, like, control under each bucket in the future, you can even do more. Does that make sense?
Do you mean like each client has its own model name and then you use the target models field?
Yes, each client, if you say, for example, let's say summarization priority, summarization lower priority, right? And both of them are going to target the same model, which is summarization in the backend. But then you can use different criticality for each of the front-facing models.
Yeah, but that breaks when a customer moves from free to paid, because suddenly to make this happen, his model name just changed, right? And all his code just went,
I think it's good to go back, like what the core objectives of the feature were there. I think the mapping, like super fine grained mapping of clients to models and tiers, is probably like wasn't in the original scope, right? And so I think one of the things we should ask would be, if you have two different tiers, if you have multiple priorities of user, and those clients, you have a free tier and a paid tier, what if, like, do you have prioritization within those? Like, so let's say within the paid tier, do you have a strict stack rank of how important customers are? Or do you have multiple tiers? Like, we wanted to take requirements on that before going down that path, but also there's a certain limit at which the more business logic those decisions are based on, probably the less useful it would be to implement it at this layer. So I think that's kind of like the guiding principle here would be how much prioritization and what are the trade-offs that you would want with prioritization. So criticality says if we can no longer serve the requests and would have to queue it, drop the request. So it's a kind of your classic, you could define a bunch of different use cases. Each use case has a model name and traffic falls off. There are plenty of other variations you might have. So for instance, you might have two workloads, one that is has a high amount of tokens and one that uses a low amount of tokens. Those are not equal. Is your prioritization based on requests, or is it based on the tokens that are generated? Because each of those has a different dimension. Tokens consume memory and linear time. Requests consume parallel consumption. So what we were trying to focus on in the first iteration was something that would be able to take that trade-off into account. And what we would like to do is kind of take requirements. My gut would be the more fine-grained your prioritization scheme is, the more likely it should be at a layer above. Or it's a requirement or an input where we'd say like, maybe this is a custom algorithm, and let's just write up the scenario that you'd like to solve. Like how much prioritization, if you don't have enough resources for all of them, which resources do you want to drop, and which of the resources on the model do you want to drop? How do you want to impact the other workloads? I think that was kind of, we kind of got that description for the base one, but if y'all had a write-up of that, I think that would actually be a really easy way for us to take a design input there.
Okay, we'll take that as a to do. But fundamentally, I think there's a mix here of, how should we call it, of deployment optimization along with routing. You're kind of deciding how much resource I need. You could think of somebody from the side, a different component, not the route, not the thing doing the routing, but a component on the side looking at what's going on, seeing how requests are coming in, maybe queuing up and whatnot, and deciding,
Mm-hmm.
trying to get more resource and juggling around the different models. Because that's what it sounds, when you read the spec, it sounds an awful lot like you're doing, priority between the models. In other words, I have n GPUs that I need to, utilize. That's all I can utilize. Now, which model do I give more resource to?
Yeah, I think the mental mindset that went into the design of this, and this is actually mirrored in like Google internal production systems, and that a lot of that deeper business priority resourcing is a separate type of system. And this attribute in this use case is actually the distinction between this is the primary traffic that should be served at the expense of all other traffic when resources are no longer sufficient. And this is traffic, so that's critical. And then default is traffic where it is acceptable to delay the execution of the request when there is no longer sufficient traffic or sufficient capacity. And then there's requests that you can say, you can drop these requests and the client will be expected to retry. And that's probably orthogonal to two other dimensions, which is like a cube system. If you don't have enough nodes and you schedule more workloads, cube does not have any concept of shedding pods. Most people implement that above cube. Most load balancers do have rate limiting and 429ing, but they're not based on multiple dimensions of resource consumption generally. So like a standard web load balancer, you typically don't have two different dimensions or multiple dimensions of compute plus memory to deal with. Some people do, but it's not common. And so specifically for for our use case and for the scenario, we wanted to start from LLMs are different. They can trade off latency for throughput. Therefore, we wanted to take some basic steps towards encoding that trade-off. But I think like, some of these other use cases, like you're very right. You may want to allow someone to make a decision between two requests if there's insufficient capacity. And queuing is as something that someone's working on, and we're trying to have some discussions about that. So that'd be great to have inputs into that. The idea that if you don't have enough capacity to serve the request without degrading other requests, put it on a queue and let something handle it. I think that's actually like a great arc for us to take requirements and discussion on.
Right, and I don't mean to belate the issue, go over the issue too much, but again, prioritizing models doesn't seem to be what you want to do. You're trying to prioritize workload.
Models are workloads. So
What?
maybe that's actually the key. We should write that down and say, in the design of the API, a model is a workload, because a base model is a generic compute platform, and the design of the API is intended to support adapters, and an adapter customize a general purpose compute for a specific use case. And so in the customer discussions we have, that mapping feels pretty natural. If it doesn't feel natural for folks, running it, perhaps the field model name is misnamed. Perhaps there's a better name for that. That was what Abdullah and I were chatting about before the call. And the original version of the API was actually called LLM use case. And for a lot of very pragmatic reasons, from people who've already deployed things like this, we picked inference model as the name of that, and model as the consistent parameter, because that's also what's in the open API request. And an adapter is served as the model name. So like, I think you're absolutely right. It is conflated, but it's conflated along a dimension that people deploying this at least have some familiarity with. And, you know, it's still early in the project. We could always
So I guess, so you're saying you're prioritizing work against a specific model or a specific LoRa adapter, whatever it be, versus looking at the requests, because I think what you really want to prioritize is the requests again. But I guess we just.
Well, but the request is, yeah, the attributes on the request have some classification, and what we are making an arbitrary statement is because you can define arbitrary model names, and the goal of the API is to translate from an incoming model name to a destination model name. The primitive that we offer for that mapping is the model name. So, Sean made this comment in chat, but your user model name can be arbitrary, and it's up to the deployer of the system to choose how to use it.
So one question that came into my mind when you were answering the question. So you said that it might make sense to do prioritization according to requests, but at least from your view, you see it as a layer above the routing, right? So let's assume we do that in a different component, a layer that does the prioritization according to something related to the user, that is in the request itself. And then we want to somehow make it possible using the infrastructure here, right? The CRDs, the fields. So how would you use the criticality field, assuming now I have a new incoming request that I want to prioritize? So how would I do that? Do I need to downgrade all the current models in order to make mine the most critical? So yeah, Shane also asked it here in the issue, in the discussion. So if you have already workloads running and the models are already deployed with some of them are critical, and now I have a new one that should be the most critical one.
Yeah, that's not supported by this field. So I would say like the use case that you've described is not supported. And so because it's the V1 and, you know, it's not the simplest possible system. So I think that'd be a great discussion to have. Abdullah and I have talked about other prioritization. And so I think there's two different dimensions here. You're talking about business prioritization to some degree.
Right.
And one of the things that we were focused on, like Abdullah and I was focused on resource utilization or resource prioritization, because two different use cases with different input output links and different latency objectives need wildly different characteristics from the same. And so it might be useful, I'm not saying this is perfectly useful, to think about the criticality field and a number of others. Those are scheduler fields. Those aren't business reordering priority fields. The use case you're describing is a business priority, and there could be many dimensions of it. We should talk through that. How do we make resource compose with business, especially when you would like to make resource trade-offs? Like some people, like if you're running a very long summarization request, that is going to cost the operator a different amount than running extremely fast classification responses at high QPS. And so I think we should try to like bifurcate those and have a bunch of orthogonal things that can work together well. That would actually be I think that would be kind of how we anticipated evolving criticality. There's like the criticality, and then how do you say two workloads have different latency objectives? And adding, if you add a very long latency tolerant summarization workload to a something that's processing a bunch of really fast requests, their latency is going to go up. And so that's like resource scheduling. And then the other one is, like how do you handle like queuing and prioritization? And that probably feels a little bit more like a classic queuing approach as well. Like queues and flow control and ordering.
Mm-hmm. Just to follow up on that again, like the idea is here, we have defined bands, and then we can introduce a business logic within each band and so that makes the API like kind of future proof. So it gives us this like, initial cut at how do I implement like the semantics where I have production versus test workload, right? And then again, like using that definition of a model as a workload, and then you can have different workloads targeting different model names, but then they get translated into something else. So you have that workaround. But then again, like in the future, based on this input and other input, like how do you want to prioritize within a band is still open for discussion. And the API allows us to expand into that.
The period of criticality was going to be basically latency objective, and then we kind of we took it out for right now because we actually need to make sure all the other stuff works. But latency plus criticality would be, if you're critical, a request that is default that would impact the latency of the objective gets delayed. And so that's the important distinction there between the two bands. But without the latency objective, we don't really have anything that models it today. And that's partially why criticality by itself seems a little bit weird, but we knew that that was a direction that we, because there's two different variables at play. Accepting a request takes up both memory and slows down all other requests. That relationship is something that we basically knew that we would have to deal with. And so criticality would mean you don't hurt workloads in a higher band. And perhaps, we go through this, we come up with a bunch of use cases that we say, you know what, let's come up with lots of bands. Let's just move to a general banding system. We wanted to start with something that was not open-ended, because we don't have a lot of other models of open-ended resource prioritization banding. Like Kubernetes has preemption that's based on priority, but in practice, everything is based on priority classes. And priority classes, the vast majority of Kubernetes deployments for scheduling eviction, all prioritization is handled with like 3 bands. And so we've seen similar for prioritization and load balancing internally. And it's just we're kind of trying to draw on lessons without being too over constrained. So I think we'd love to talk about prioritization within the band as a separate, like as a design, like y'all want to accomplish X, Y, and Z. And then we can ask the question, how does that interplay with resources? And when resources are constrained, what should happen to requests within a band?
Cool. Yeah, I think this is a great conversation. Agreed. The criticality field is it was a choice we made. That was for sure. We definitely knew we were making a decision. I do want to mention that we also can think of the inference pool as not just a gradient of a single product. An inference pool can be multiple products within. So how do you have your let's assume we're a smaller shop and you have all your accelerators in one pool. How do you keep your business critical workloads running while also sharing with some of your dev stuff? That's where that sheddable comes in. It's like, look, we can't do this right now. Let's move that aside. So I think Clayton nailed it when he's talking about, your business logic priority versus your straight up resource priority. Like what do we have to hold on to keep this ship running? So that was our thought there. But anyway.
I'm sorry.
Yeah.
I don't mean to beat a dead horse. I'm sorry. So, by the way, I work with Nir from IBM. I work with Nir here in Israel. As an aside, it's a very short introduction. The issue I have, the idea of the prioritization is very good. Okay, that there's critical work and there's less critical work, etc. Right, that's sort of on the way to an SLA or SLO at some level, right? Again, my issue is that it's on the model and not on the request. That's the problem.
But what's on the request? And so like, what is the field on the incoming request that we would base it on?
Maybe, so there will be headers. So theoretically, so I understand where you're coming. You're coming that, there's only so much in the OpenAI API, right? And it's clearly not set up for things like this, apparently, right? So they have to, right? And in general, adding another field to the payload is the wrong thing to do. Just like it's the wrong thing for the routing, it's no different. So it's clearly headers of some kind, okay, that the user can say, I'm this kind of workload, Okay. Now, in general, you need some kind of authorization here, because even if you do it by model name, you still need some way of saying, you're Google, I'm IBM, we have a big SaaS operation, right? And people are paying for priority versus people who aren't paying for priority. We want to control this. We don't want just, somebody saying, well, my stuff is high priority. I didn't pay for it, I'm really cool, right? So there has to be something somewhere. It can be part of the gateway, part of the router. It can be some API pod that runs before that validates the request. Right? This could be even metering, dealing with metering, billing, API keys, all those things have to get done.
So
Yeah. Okay, Tom.
just so first things first, I think, and Clayton kind of touched on this, I think we're open to the idea of a numeric based priority system. But setting that aside for a moment, let's assume that you only have 3 cost classes. Just for the sake of argument. Should you want to use a single model and have those 3 cost requirements, you can make, and again, maybe, the naming is poor. Love the feedback, not kidding. What we were trying to do with our model CRD is say, use a single base model, go ahead and let whatever thing that is going to call into your LLM service, let it figure out that off. Is this customer priority tier? Cool, go to Llama 7B priority. And then that goes to the same base model, but it's now critical. Or do, base tier, and then it's still the same base model, but you use that indirection. This is now standard versus, okay, this one's a trial user, they get shuttable. And it all still goes to the same base model. We use the term model. Maybe that's poor. Fair enough. I would love to workshop on that name, but that's what you could get around that.
So that works. So I'll claim that works if you're only dealing with base models. Once you start dealing with bring your own LoRa, right, this will scale out of control.
True. Yes. If you have 3 tiers on 100 adapters.
And I think that's also like part of the system design goals. This project, like some of the scale design goals, certainly are things that can be represented at reasonable scale in the Cube API are part of scope, and things that cannot be are not in scope to start with. So like 10,000, like I think we set some. We did. I don't know which of the docs has this, but we set some reasonable scale, and we think 1,000 to 10,000 CRDs for model name would be what a reasonable V1, V2 goal would be. It doesn't mean that there may not be use cases that people come up with that say, oh no, we want tens of thousands or hundreds of thousands or millions of CRDs. But if your system would support tens of thousands of users, I would say that the CRD is not intended for that use case in its current scope. And so to grow scope, we would want to have the discussion, like, is that actually the right modeling at all? And I think I would agree with you. Modeling users on CRDs is not the modeling we're intending. And if there's a need for an extensible prioritization engine, like that has been kind of discussed in the extension work, which would be for everything that is part of the core algorithmic that needs to share resources fairly and to do balancing and to make some of the, if we don't have enough resources right now, we would drop A or B. That probably would be best described as a system alongside. And so, yeah, I think you're right. We as a project don't want to get opinionated about clients, but we do want to offer a good primitive that can be used for small O modeling. And you can, in a small team, 100, 200, 500 workloads, you can absolutely abuse the model name or use as intended for some of that. And when you start hitting the limits of that, that's either both a design change in the project or it's a points to a need for another system. So I just think certainly the current scope of the project was not intending to support multi-tenant cardinalities above 10,000. And I think it'd be open to the discussion for sure. You know, as a, what would an API that, you know, if you wanted to support some of this stuff out of the box, what would be the primitives that you would need, like priority within models? And is this something that should be represented in those CRDs, or would it just be better to let the endpoint decision actually delegate to a system that's, you know, making the decision for you based on another set of characteristics beyond just basic resource use?
Cool. This was great discussion. I really appreciate it. Moving along, Jiashin, we'll jump to you at checking time. We got 10 minutes. The CPU image for testing purposes, I see that you brought that up. We discussed that a little bit. Did you want to dive in further?
No, I think we're good enough now.
Cool. Cool. And then I wanted to just call this out. We worked with Envoy quite a bit through from initialization to now v0.1. So we would love to get an Envoy gateway integration. Wanted to reach out to the community to see if anyone was interested in doing that integration. I think it would be it's a really cool way to get involved in the project. Throwing that out there. If you have any questions, you can DM me on the Kubernetes Slack, or reach out to me on GitHub, however you'd like. But yeah, would love to call that out. Cool. All right. Unless there's anything else, I think that's it. Thank you all so much. Have a good rest of your week.
Thanks.